like 407. All right, so we started the reading for 2D arrays. Right. Today I'm going to go through all of the content for 2D arrays, even though some of it is due on Wednesday. But so on Wednesday, we're going to talk about good debugging practicing. And we'll also go over we'll start general, right? And then we'll look into how you can debug in MATLAB particularly. All right, so what are these 2D arrays used for? Any application? Yeah.
To store multiple arrays.
Yes. Very general, right? But more specifically, why do you want to be able to have a 2D array? Why not have everything be 1D arrays? Yeah.
Tables and this.
Yeah, so one example that you saw was table information. What else? There's a different example in the reading that was like the first thing that it showed you. What are we looking at right here?
That's an array of pixels.
Yes. And how many dimensions? Not the specific size, but how many dimensions, right? To create yes, an image. Anything else we got? Why else do we want 2D arrays? Let's look it up. 2D array applications. Can be as simple as like layouts. Like you have a 2D grid representing, say, like this room. And zeros means it's empty space for like hallways. Ones means it's like use space for these lab computers. Right? There are many other applications. It'll come up, right? When you see it, sometimes you should be thinking, oh, 2D array for this is good, rather than 1D array. Right, so indexing into a 2D array, we already covered this in the very first few lectures, right? But there is one thing that we should specify. When you are indexing like this, just know that it is row column indexing, as in the first number specifies the row, second number specifies the column in that row. But there is another form of indexing called linear indexing, where even though this is like a 3x3 array, right? If you try and index it with one number, then this is how it would be laid out. It goes 1, 2, 3 of the first column, then all the way back to the top of the second column, 4, 5, 6, 7, 8, 9. And this is the general form it takes for any size 2D matrix. So it reads column-wise. So then, if your column size is, or I mean your row number is m, then this is your formula for if you're indexing with the two numbers. This is converted to a linear index. Right? You're basically multiplying by the number of rows to tell you which column you're looking at, and then where am I going, how far am I going down, which is kind of like which row I'm looking at, right? And then we subtract 1 because if we're accessing column 1, then there's no need to have this offset, right? Because then x would tell us 1, 2, or 3. Right? Are we good with this linear indexing? Yes.
C plus X.
Okay, so let's just do an example. So let's say that we wanted to access 3, 3, right? So this is x, this is y. So y minus 1 is 2. M is 3. So this is 6. So basically it's telling us to skip column 1 and 2 because I'm trying to access column 3, which is 1. Right, so that's why the minus 1 is there. And then the 3 for the x, so plus 3 says I'm going to the third one in that column. And this is x. Is that better?
Yeah.
Okay. So concatenating arrays, so just like we showed you guys in the first few lectures, you can create concatenation arrays either vertically or horizontally. There are many different ways that you can do it. So if you want vertical concatenation, it's like creating more rows, right? And you just can do it with the array creation by using the semicolons, because as we learned, the semicolon means new row, right? And then if you wanted a horizontal concatenation, you use commas, because a comma means new elements in that row, right? And then you can also use this built-in function called cat. 1 specifies vertical, 2 specifies horizontal, and then there's these other options, vertcat, horscat. So there are many ways to concatenate multiple arrays together. All right, so 2D array indexing. This part, I'm mostly talking about using arrays to index into arrays, right? We learned about that with the previous lab as well as 1D arrays, right? So in the same way, 2D array indexing with arrays works exactly the same. So let's see. What do we want to make as a 2D array? Do I 5? So here's a 2D array. I need to save it. So A is I5. Now for array indexing, if I want all the even rows, what would I put as my first array here? What do I need to start at? What index? What's the first even index? 2. What's my stride? Right? And how do I specify where I want to end at? So this should give me all of the even rows. Now let's say that we want all of the columns, every single column. You can just put a the colon. And now that returns row 2 and row 4. Okay, so we input an array to index into the 2D array. It's just now with 2D arrays, we have 2 arrays that we can input. Like if I just wanted the first column, do we see? Okay. That is our 2D array. All right, so deleting an element in a 2D array, how do we think this will work? Okay. So let's say A, which element do you want to delete? 2, 1. And we want to do this. Do we see any potential problems with this?
It won't stay at the rectangle. Or
Yes, because, so which one is 2, 1? This is 2, 1, right? So if we remove this, what does this row, its dimensionality becomes when it is supposed to be? So then we get you can only do this to 1D arrays. Because the 1D arrays, there's no restriction on the array above it or below it needs to be the same size. So usually if you're deleting elements in a 2D array, you give it like either 0 or maybe not a number, right? Because we can do that. So not a number. Okay. And now if I do something like A times 2, right? The not a number just stays not a number. What about deleting an entire row or an entire column? Can we do that? How do you think we would do that? So AS what? Do we want to delete a row or a column? Okay. So we'll get the entire. Well, which yeah, so the entire row, what column do we want to delete? 3. What do you think is gonna go here? Like this? And it's gone. Right? Column 3 was 1, 2, 3. This one. And the one with the gone. Skips from 2 to 4 now. Yes.
How's that different from just deleting one element because it looks almost
Because here, this is returning a vector. It's a, what is this going to be? A 1x5 vector, right? So we're assigning that it's going to be now an empty vector. This returns a 1x1 vector. Right? And we're trying to assign the 1x1 to be empty, but then when it goes back to the array, yeah. So the other thing is you can delete single elements, like say with the linear indexing. Say we want to delete A at 5 is 0, well, nothing, right? Just deletes it, but then your 2D array becomes a 1D array. So do be careful if you're meaning to do something like this, but you end up doing this with linear indexing. Just be aware it becomes this 1D array afterwards, which might be a bug, right? And we'll talk about debugging. All right, so your arrays also have these different properties. I saw some of you guys already using the length function. Okay. You can also get the number of dimensions, the number of elements, as well as the size. And basically the size is returning the, in each dimension, how wide is that dimension, right? All right, so another thing that you can do is reshape arrays. So like here we have a 1D array, 1, 2, 3, 4, 5, 6. We can reshape it to a 3x2. And the way that it reshapes things is exactly how the linear indexing works. Because when you're reshaping a 3, 2, maybe you wanted 1, 2, 3, 4, 5, 6, right? But the reshape function creates columns first. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So here is 2, 3. So 1, 2, 3, 4, 5, 6. So if I wanted 1, 2, 3, 4, 5, 6, what I should do is reshape a 2, 3, and then transpose it. Right? So you can achieve what you want with the reshape function. You just might have to do some additional. Basically, it would just be transposing. And 1, 6, again, it's creating the columns. So 1, 2, 3, 4, 5, 6. This makes sense? Right, and our size has to match the size of this. Right, we can't say like 5, 3. Right, 5, 3 is how many total elements? 15. Right? We have 6 elements. It would give us an A. Alright. You can also sort arrays. So the sort function returns two things. It either it's going to return the sorted array as the first return. The second return is basically the indices that make it sorted. So here we can just do an example. Let's make a 4, 6, 2. Right? So 4, 6, 2. And then new A, comma, AI, or A index is sort A. So this is the sorted array, 2, 4, 6, right? In ascending order. But this is saying that I need to put the third element here. The first element here, second element here, and this sorts the array. Right? So the third element is 2. First element is 4, and the second element is 6. So this can be useful in some situations. Maybe you don't want that fully sorted array. Maybe I want the third lowest number in the array. Then I can just grab A index at 3, and then the array at that number, at that index, right? And then you can also do sort rows, because we have 2D arrays, right? And you can sort columns as well. I think if you have a 2D array and you just do sort, it sorts columns by default. And then element-wise operators. How do we do element-wise addition between 2 arrays? 2 1D arrays. Like let's do, so we already have A, right? 4, 6, 2. B is 1, 3, 4. I want to add these 2 things together. What do I do? Element-wise. Like this. Are we sure? Try. Doesn't like this. For plus, it's just plus. Right? This is A plus B. But how do I multiply them? Element-wise multiply them. Do I do this?
Dot.
Yeah, this is where I need the dots. Okay. Because if we try and just do this, it's trying to do what? Matrix multiplication. The reason we don't need the dot for the plus is because matrix addition is element-wise addition. So for elements wise addition for 2D arrays, what do we think our operator is? Because this was a 1D array, right? What do we think our operator is for 2D array? I'm not trying to fool you.
It is plus.
It's just plus, right? Just plus. So let's try it. Let's make it I3, and let's make B also I3 to make it simple. So A plus B, right? And if we want to do multiplication, what do we think the operator is? Right? Maybe I should have chose something else, because if I do this, the result is also this. But that is still the distinction. For 2D array, it's also the normal multiplier operator is matrix multiplication. The dot multiply operator is element-wise multiplication. We have plus, we have minus, we have dot, star, we have dot, divide, right? Okay, so that is coverage for 2D arrays. You have more reading on 2D arrays to do to prepare you further for the lab on Friday, and Wednesday we'll talk about debugging and debugging MATLAB. So we have 20 minutes left. You guys can get a head start on your Zybooks. You can work on the lab. Does anyone have questions though?